Okay, so here we go with the EC312 6-week exam, Spring 2022 practice exam. So I'm just going to walk through, explain what I would do for each of these questions, and hopefully shed some light on the answers. So for the first one here, it says, suppose that the following program is compiled and executed, and it gives you a program with some variables and a for loop. So generally here what you're trying to do is just understand what the C code is doing and understand how a for loop executes. So what I usually like to do with these types of problems is just sort of write out the variables, so counter and inc. In this case, those are the two things that we have in the program, just starting at main and looking at what's there. And I want to write out what their values are. So counter is starting at, 5, and inc is starting at 4. And that's just reading the initialization statements here. Moving on, we see that the for loop starts and it initializes counter to be equal to 0. So the first thing that happens in a for loop is we initialize the variable, and so counter changes from 5 to 0. We then, for a for loop, check the condition. So we check to see is counter less than or equal to 12. And so we say 0 is less than or equal to 12 is true. So that means we're going to execute the for loop. So we just basically check that condition, and then we go into the body and see what happens. So if counter is less than 6, we're going to print a number, which is counter, and then a new line. And so the first time we execute this, we're going to print out a number. And that's going to be important for the part B here, which is what is the output of the program. So we can go ahead and start filling that out as we walk through this. So we're going to output counter, which is going to be 0. And then we're going to have a new line. So the next time we output something, we're going to go to the next line of the output here. That's all we do here, right? Since it's an if, and it was the if case, so we do that. And then we skip the else. We loop back up to the top. We're going to do, at that point, the increment. So the way the for loop works is after we run the body of the for loop, we are going to increment the variable by whatever condition it has here. So it says counter equals counter plus inc. So counter, which is 0 right now, is going to be changed to counter, which is 0 plus inc. So 0 plus 4, counter is going to become 4. Okay, we check the condition. 4 is still less than or equal to 12, so that's true, which means we're going to run the loop body again. So counters again, 4 is less than 6, which means that we're going to print out that value again. Again, it's just print %d means an integer, new line, and we're printing out counter in place of that %d. So we loop out back up to the top. We run the increment again. So counter equals counter plus inc. So 4 plus 4 becomes the new value for counter, which is 8. We check the condition. 8 is less than or equal to 12 is true. And so now we go into the body of the loop. If counter is less than 6, that's no longer true, right? Because counter is 8, and so we're going to go to the else part of the condition, and we're going to print go Navy. And again, there's a /n there, which means that we're going to have a new line. We'll move on to the next line after we execute if we print something else. Let's loop back up to the top. Counter equals counter plus inc. So 8 plus 4, counter becomes 12. 12 is less than or equal to 12, right? It's the equals part, so it's going to be true that is what we have here. And so then we're going to go into the loop again. It's not less than 6, and so we're going to print go Navy again. And then we're going to go back up to the top, and it's important to remember that this counter equals counter plus inc happens here. And so we're going to do 12 plus 4, and counter is going to become 16. Because we do that, and then we check the condition. So then we check 16 is less than or equal to 12, that's false. So that's what causes us to exit that for loop, meaning that counter has become 16, and so the final value of counter is 16 here. So it's really important to remember that increment, whatever the loop update is, happens, and whatever makes this condition false, like this condition should be false at the end of the loop. And that means it retains that value. And sometimes it's a common mistake that people think that it sort of updates and then goes back to 12 because that was the last time that we ran the loop. But it has to be something that makes the loop not run anymore. So that's problem 1, just really looking through a for loop and analyzing what's going on. So let's move on to question 2 here. For question 2, it says, answer the following questions using the memory diagram shown to the right. So we're just looking through, trying to analyze what's in memory, looking at the hex and converting it to some values for the most part. So part A is fill in the missing portions of the addresses. So we're looking at the left column here. This is just asking us to count in hex. So keeping in mind that hex goes 0 to 9 and then A, B, C, D, E, F. and that A, B, C, D, E, F corresponds to 10, 11, 12, 13, 14, 15. And so that's what we're looking at here. When we go for 2F9 plus 1, we're going to go to 2FA instead of to 2F10. We're not looping over because we're in hex, so we move up to A from 9. And then likewise 2FB, 2FC becomes 2FD, 2FE, 2FF, and then of course here's where we're in hexadecimal math, so we have no digits beyond F. This is just like when we're counting in decimal and we get to 9 and then we go up to 10, which means we change that digit to a 0 and we carry the 1. So that's going to become a 0. We carry the 1. We have to carry again because that's an F, so we have to carry that one further position, so that becomes a 0 and this becomes a 3. So again, 2FF plus 1, we become 0, carry the 1, and that's 1 plus 15 is 16, and because we don't have a digit for that, it becomes carry the 1. So 300 is what we see there. And sorry, I had that off screen, but that's the calculation we're doing, is just 2FF plus 1 becomes 300 because that's the highest digit. So just like in decimal, if we did 199 plus 1, we would do 0, carry the 1, 0, carry the 1, and then that would become 200, right? So we're just working in hexadecimal math instead of in decimal math here. So part B, suppose you were told that an int is stored at BFFF2F6. BFFF2F6. So let's find that on the diagram. There's BFFF2F6. And keep in mind that this is an integer. So for an integer, we're looking at 4 bytes of data. And so we want to get 4 boxes starting at the address that they specified. And then remind ourselves that integers are stored in little endian, which means the lower end or the little end of the number is the first thing we see in memory. So this is the sort of rightmost bit or rightmost byte of that 4-byte number. This is the leftmost byte of that 4-byte number. Otherwise, they stay in order. So our value at 2x or OXBFFF2F6 is going to be OX00. That's the bottom box. 00. It's the second box. 11, and then 10. Important to remember that the 10 does not flip to 01 here. It is in little endian order, but the bytes are listed in the correct order. So these individual boxes are in the correct order, but the group of 4 boxes is in little endian order. Okay, so now that we've got this hex value, we want to determine its decimal value. So we've got a hex number, and we want to remember that hex numbers are represented as, these are powers of 16. So this is really 0 times 16 to the 0, plus 1 times 16 to the 1, plus 1 times 16 squared, plus 1 times 16 to the third, which is going to be 4096, plus 256 plus 16 is going to be equal to 4368. So we're just converting from hex to decimal here. In this case, you can show work if you're not sure if you're getting the right answer, but for the most part, you should be able to just use your calculator. And please do look up how to convert from hex to decimal and decimal to hex and etc. Those to binary as well on your calculator before the exam. So for part C, suppose you were told that a string is stored at BFFFF2FC. So let's start and find there. So this is our starting address. Now a string, we have to remember that a string is going to be however many bytes until we see a null terminator, right? Strings are variable length. That means that we don't necessarily have a finite amount of data here. It's not like an integer where we know it's 4 boxes because integers are always 4 bytes. So we're looking from this letter until we see a null terminator. And so I'm going to read down from there, and that's the first null that we see. So we're gonna stop at that point. The 00 represents a null, and that means we're going to have 3 characters in ASCII, and that's going to be it. This again, characters are arrays, and so they are stored in order. Starting with the topmost address. This is not like an integer where we have to flip it into little endian order. So here we have 24, then 39, then 37, and we'll need our handy dandy ASCII chart here. So if we look at this, it's very small, but 24 is here, and that's a $sign. So we're gonna have a $sign, and then 39 we can find is here. That's a 9. So 9 represented as ASCII. Keep in mind that digits can be represented as text. And then 37 is going to be a 7. So that's $97 or $97 is the string that we have in memory. That's it for problems 1 and 2.